Hi, my name is Grace Koenig, and for my motion video, I filmed a ball rolling down a wooden incline. This is the video of the ball going down the incline. Newton's first law relates to the ball in motion because the ball was originally at rest until it was acted upon by an unbalanced force of gravity, which was when I let go of the ball. Then the ball came to a rest again because of the unbalanced force of friction between the ball and the wood. When the ball was rolling down the incline, I marked where the ball was at each second. To get the position versus time calculations, I measured the distance between each mark in centimeters, then I converted it into meters. To calculate the ball's velocity, I used the formula velocity equals change in distance over change in time. The data shows an increase in velocity. Since the velocity was not constant, the ball was accelerating due to gravity. To calculate the acceleration, I used the formula acceleration equals change in velocity over change in time. This is the position versus time graph of the ball. I used centimeters versus seconds for the units on all of the graphs. The ball's position was not constant. It increased over time at a higher rate. This is the velocity versus time graph. The ball's velocity was not constant. It also increased over time. This is the acceleration versus time graph. This is the force diagram of the ball. As the ball rolled down the incline, the normal force, force of gravity, and the frictional force acted upon the ball. The normal force is the force that the incline exerts on the ball. The force of gravity is what causes the ball to go down the ramp. And the frictional force creates heat and is caused by friction between the incline and the ball. This is the energy diagram of the ball when it was at the top of the ramp, not let go of yet. The ball's energy was all potential energy because there was no velocity from the ball moving. This is the diagram of the ball's energy when it was halfway down the incline. The potential and the kinetic energy are equal because the ball gained velocity and lost height. The total energy decreased due to the friction. This diagram shows the ball's energy when it was at the bottom of the ramp. Its potential energy was lost because the ball had no height at this point. The ball only had kinetic energy because it had velocity. The total energy decreased even more because of friction. The change in energy is the work done. When I placed the ball at the top of the slide, I did work on it. I transferred energy from my body to the ball, and it became mechanical energy. These are the calculations of the ball's kinetic energy at each second. Its kinetic energy levels were very low because the ball only weighed 25.5 grams. These are the calculations of the ball's potential energy. The potential energy decreased over time because the height of the ball decreased over time. Here are my citations. Thank you for watching.